Okay, everybody. So in this video here, we're just going to do a quick example of rationalizing and simplifying. And in this case here, we've got the radical in the denominator. So we're going to rationalize the denominator. And because it is a binomial denominator, I am going to multiply by the conjugate. Okay. And I have to do this to the numerator denominator so that I am consistently multiplying by 1 when I do this. And notice that it would help me out here if I put parentheses around that numerator here, just so it's clear that I'm multiplying that root 3x minus 2 plus 2 by both those terms and not just the negative 8. I'm going to focus my attention right now on that denominator that I'm rationalizing because I want to make sure I get that right there. So when I multiply by that binomial conjugate, I'm creating a difference of squares. So my first term is going to be the square of the square root of 3x minus 2. So essentially the radical is going to cancel here. But don't forget, and this is a common one, so we just multiplied those together. Don't forget that now we're going to multiply the negative 2 multiplied by the positive 2, and that's going to get me negative 4. And when I clean that up, I get in the denominator, so this is, there we go, root 3x plus minus 2 over, plus 2 all over. This is going to be 3x minus 6, okay? Now, I can, out of the denominator, take a 3, and I'm left with x minus 2. Now, that should jump out at me right here because notice this binomial up in the numerator there, this x cubed minus 8, that is a difference of cubes. And so the way the difference of cubes is going to work here is it's going to be the cube root, and because it's x cubed minus 8, I'm going to do cube root minus the cube root. So cube root of x cubed is x, cube root of 8 is 2. And then this is going to be x squared plus, okay, the product of those two cube roots there, and then we add that second one squared. Now, the assumption is at this point, I mean, clearly that you have seen this before, this type of factoring here. This is why I'm not going out of my way to explain what's going on here. If you're not sure, I'll just put the example over here. If you've got x cubed plus or minus y cubed, that's going to be x plus or minus y, x squared minus plus xy plus y squared. That is the pattern that I'm following there. So at this point here, I can cancel the x minus 2's, and I'm going to be left with 1/3 x squared plus 2x plus 4 multiplied by the square root of 3x minus 2 plus 2. And this is almost exactly equal to the original expression, except the original expression had this non-permissible when x is equal to 2. So to make these equal, I'm going to have to include that x cannot equal 2. And now they're equivalent to each other.